Hi everyone, this is Christiana Malta, and for today's video, we were tasked to demonstrate the functions of different materials and tools, and it is our video assignment in Eetvet 1. The first tool that I have here is the long nose pliers, so it is used for stripping wires, holding wire in places while inserting screws or nuts. It also can be used to grip small objects and bend wires or bend loops. So for example, I have here a solid wire. So I want to bend this wire using the long nose. So just put the long nose like this and then bend the wire. And then as yes that. And also, long nose can strip wires like this, for example. So for the next tool, I have here diagonal cutting pliers. So it is used to cut wires, small pins that cannot be reached by larger cutting tools. So for example, I have here this one, the Y splice. So I will cut these small pins using the diagonal cutting pliers. For example, if I want to cut the pin of this charger, so diagonal cutting plier is the best option. So we can easily cut this wire using the diagonal cutting plier. And for the next tool, I have here the tape measure. This is the thumb block, the case of the tape measure. These are the hooks and the blade tape. So the primary purpose of the thumb block here, if I push down the button, it will lock the movement or prevent the movement of the blade tape. So it will prevent the blade tape from going back to its case. And if I push the button upwards, it will enable the blade tape to move back to its case. And the reading and the measurement below indicates the reading in meter, and the measurement above indicates the reading in feet. So for example, I'll be measuring this plier. So it is 18 centimeter. For the next tools, I have here electrical tape. So it is a pressure sensitive tape used to insulate materials that conduct electricity, specifically electrical wires. So for example, I have here a broken wire, and to possibly prevent an accident, so I will connect these two broken wires using the electrical tape. Just make sure that all that the broken wires are perfectly covered. So for the next tool, we have here tacks with screw. So a tacks is a type of wall plug or anchor, can be used in concrete, in wood, and even in masonry. It is needed when a screw has to be attached to a porous material or a brittle one. So the tacks with screw helps support the weight of the object. So for this, we will be needing a screwdriver that will drive the screw into the tacks. So for example, for this is the mounted cover of wall fan. So next is the rubber tape. It is designed for use in splicing and terminating wires and cables with options rated up to 69 kilovolts. They have excellent physical and electrical properties and are ideal for adding moisture protection to electrical connections and cables. So for example, if there's a wire, so this wire has a rated up of 69 kilovolts or more, and it is extra protected with the use of rubber tape. For the next tool, I have here cable lugs or devices used for connecting cables to electrical appliances. So in this part of the cable lug, it is typically used for connecting a cable which should be soldered, welded, or crimped, and in this part, it is fastened to a matching terminal or connection point by means of a bolt or screw. So I will show you the process and how it is done. So first, we will be needing a crimping tools, cable, and cable lock. And then, first thing is to strip off the cable insulation. And then after stripping the cable insulation, we will insert the cable conductor into the terminal. And after inserting, we will make sure that the cable conductor is fully inserted by inspection hole. And after that, just crimp plug. And after crimp plug, um, it is a completed crimp, and that is a how cable lugs is used. It is an example of a cable lugs. It is a wire conductor that is inserted into the cable lugs and the other end also was inserted and is fastened by a bolt or a screw. For the next tool, we have here splicing connector. It is a plastic clips used to make quick splices or connections with two or more pieces of wire. It consists of a plastic clip with a sharp metal insert safely through the plastic insulating jackets. So this wire here will be inserted to the hole, and after inserting the wire, just push the button down to make it lock. And also we can add more wires, one wire here, and same process. The next tool we have here fish tape, also called a pulling type duck threader, can be classified into steel fish tape and fiberglass fish tape. It is widely used in pulling electrical wires through electrical conduits. The term fish comes from the fact that it's nearly impossible for us to push a wire through conduit, and then we must first fish the tape through the conduit. So for example, this is a room. I have here a circuit breaker, and I want to put a wire to this end and to this end, so I will be using the fish tape. In the formal way of getting more wires, so these are fish tapes, and this is the hook. And for us to get more wires, so I will put my left or right hand here, and then the other hand will be pulling this button until it will produce more wires. And after, I will insert the hook of the wire here into the hole, and then push until it will go out this hole. And after that, put I will prepare some wire. For example, I have here two wires and three wires, and then this wire, the end of this wire will be bended like this, and then the hook of the fish tape will be inserted to this part. And after inserting the hook of the fish tape, so I will put some electrical tape here to ensure that the hook of the fish tape and the wire would pull away from each other. So after securing the wire and the hook of the fish tape, so put the I will put the wire together with the fish tape to this hole, and I will pull the remaining part of the fish tape here until the fish tape will go out together with the wire. So that's the process of using the fish tape. And for the last tool, you have here multi-tester. It is a measuring instrument that can measure multiple electrical properties. So it is classified into two types. So we have digital and analog multi-tester. So for now, let's have first the digital multi-tester. So let's identify the parts. These are the probes, the The black proofs indicates negative and the red proofs is positive. The insert jack, the range, the display screen, the button. And for AC, we have the sign. And for DC, so for example, we want to test the volts of this battery. So battery is a typical example for direct current. So first thing is to rotate the range into this direction because it is where the direct current is located. So we will choose let's say we will connect the volts up to this 20 and then connect the pin of the negative proof to this side. So we will assume that it is our negative terminal and this one is for positive terminal. And upon connecting the proofs to the terminal, so the display screen will automatically display its readings. And if we interchange the connection for proofs, for example, I did connect the negative proof to the positive terminal of the battery and the positive proof to the negative terminal of the battery, so the display of the reading give a negative reading. In the case of AC, there is no polarity, so it is okay for us to interchange the the connection of the probes. And for the next one, we have here analog multimeter. So these are the parts of analog multimeter: the pointer or the needle, the scale, the zero position adjuster, the range selector knob, the 0 ohm adjuster knob, the test probes, and the test pins. So this is our analog multimeter. So for example, I have here a resistor, and this resistor has a resistance of 100 ohms. And for us to know the resistance, so first let's turn the range selector knob into this part because it is where the resistance is located. And for us to know that to set the resistance, so we will just connect the pins of the two probes. So upon connecting, so the needle will automatically be pointing here. That means that the analog is in good condition. And if the analog and the needle will not point on the 0, so we will use, that's the time that we will use the 0 ohm adjuster knob. And then we will choose where to directly put the arrow. If we will put the arrow to the times 100, to the times 10, or to the times 2, to the times 1. So first let's have the times 100. So we will see that the needle of the analog multimeter won't move. It is because times 100 is too high for our chosen resistor, which that has a 100 ohms. So we will try to put the pointer to the side to the times 10, and then the needle will automatically be pointing at this side at the 10. So to know the reading, so we will just times the number here and the number here. So 10 times 10 is 100 ohms. So that's the reading. For example, let's have another resistor, and if the needle will be pointing at this side, so to know the readings, we will count the lines, so 1 2, so it is pointing at the line 2. So in this part, we will apply the minor and the major division theorem. So major division and minor divisions, we will count the line. So this one indicates the line. So it is the 0 to 2, 2 to 10, 20 to 50, 50 to 100. So in our case, the lines is connected between this number 20 to 50. So we will see. So yes, it is between 20 to 50, and it says that 20 to 50, and it is in line 2. So In 20 to 50, the minor division, so each line contains 2, so this will become, so the reading for materials for the resistor here will become, so 2 lines, so 2 plus 2, and it is in 20, so 20 plus 2 plus 2 is 24, and times 10 is 240 ohms. So for the next resistor, we will be having the resistance of 240 ohms.